So welcome everybody to another live coding workshop for Sciences in Parks. This time we're going to focus on using R Studio and data visualization. It's a 1-hour workshop, so it's going to go by really quick. If you don't know me or this is your first time attending one of these webinars, my name is Jessica Johnston. I work with the Ecological Society of America, and we are a partner of the Sciences in Parks program. Our partnership involves engagement, so we host webinars and workshops for professional development. We also host affinity groups, and we do site visits. We also make those handy-dandy Sip Scoop newsletters too. So I'm really here as the technical support today, and I'm going to introduce my former professor in coding extraordinaire, Catherine Hulshof, who is an associate professor. Am I remembering this right? At Virginia Commonwealth University, and is also a certified data carpentries instructor, meaning that she has the tutelage and the experience to teach you how to code. So I'm going to pass it over to Catherine, and you all have fun. Reach out, use the chat box whenever you need to, okay, if you need to communicate with us.
Great. Thank you so much, Jessica, and thank you for coordinating this. I love everything ESA, everything National Park, so I'm excited to be with you on your R and programming journey. So like Jessica mentioned, I'm an associate professor at Virginia Commonwealth University. I'm an ecologist, a plant ecologist. I study plant diversity across elevation, across mountains in temperate and tropical latitudes. I've been coding for 15 years now, before there were online resources for R. And I know it can be overwhelming to begin your programming journey. So the point of this hour is not that you will become an expert, but what we want you to get out of this 1 hour is that you feel more comfortable navigating our studio, and that you're more familiar with the online resources and tools to get help when you need it this summer. Today we have 2 helpers who will be monitoring the chat if you have questions. Alex and Andrew, do you want to introduce yourselves?
Sure, I'll hop on. Hey everybody, I'm Alexandra Julik. I'm a marine ecologist and a postdoc at the University of Florida. I was also a 2021 SIP intern, where my project largely focused on analyzing a really large database that the park had on sea turtle nesting. So definitely used a lot of coding and analytical skills for that. It's great to see you guys all here. I took a very similar workshop to this, like back at the beginning of grad school, and I referred to my notes for this course for a really long time. So yeah, this is super handy. Like Catherine said, you won't be an expert, but it will provide you with the tools you need to move forward. So yeah, I'll turn it over to Andrew.
Sorry about that. Can you hear me? Okay, cool. Hey, so my name is Andrew. I am a data scientist now working in local government, but I got a PhD in animal behavior, and I was also in the 2021 SIP group. And I worked with a really messy, a really big, somewhat messy data set on breeding birds in Isle Royale National Park in Michigan. Some of you may have been in the last one, but man, I could have really used that Open Refine system to help me deal with that data. And I also have to really highly recommend the data carpentry stuff. I took like a half semester course with the data carpentry system in grad school, and it was by far the most useful stuff that I got in any class in grad school, even though it was only half a semester. And yeah, you know, even if you don't learn you won't learn how to do everything in this workshop or any workshop, but at least you'll know how to Google it, which is really the trick. Once you can understand it enough that you can Google it, then you're golden. But yeah.
Great, thank you. I'm excited that you both of our helpers commented on the carpentries because that's where we're going to start. I'm sharing my screen. Hopefully you can see, I've pulled up the Carpentries Are Ecology lesson. This last week's tutorial and this week's tutorial were both based on carpentry's curriculum. And what's so powerful about that is the carpentries are recognized worldwide for being a leader in data science pedagogy. Pedagogy is like the science of how we teach data science. So they're leaders in that sphere, but also when you put this on your resume, that when you you can work through these tutorials on your own and put that on your resume, like people will recognize and have a good sense of what level of understanding you have in your programming journey. I've also linked to it in this SIP help sheet, which we'll get a link to in the chat as well, so you can have the link to this website. So we'll be following their curriculum. We can't get through all of the material, but like Andrew mentioned, you'll know how to Google, you'll know the website to reference. Alexandra mentioned as well, she's referenced this website throughout her research as well. So it's a good place to come back to because we can't go cover all the material, but we'll get you to a place where you feel comfortable using this resource. Okay, so now I have to do some wiggling of the windows. And now you can see the RStudio, I'm hoping.
Yes.
Okay, thanks. Great, so we're going to start with a description of what is R versus RStudio. R is the programming language, and RStudio is this interface that we use to interact with the programming language. It makes it a little easier to navigate, and we can save our script. So we'll talk about like what all these windows are and how to navigate RStudio. The reason why R is such a great language to learn is because it's great for reproducibility. You can create a script, a code, save it, send it to a collaborator, or come back to it, your future self in a year, and reuse that code for to rerun your analysis or to run the same analysis on new data. R is used across many different disciplines, across many different agencies as well. So it's a good tool to know, and it produces publication quality figures, which we'll see an example of that today with ggplot. So RStudio is divided into 4 windows that you can customize and move around. And let's talk about the individual panes. So this upper pane is the source. This is where we'll compose our scripts and save them. In the upper right, there's traditionally this environment history window, which shows you your working space, your command history as well. Down here is the files, plots, packages, help. It's a good place to refer to help, to see the plots, and to see what files you're working with as well. And then this final pane is called the console pane. It's where the commands are actually run. You can customize these, the placement of these panes in global options. You can do a lot of customization to RStudio under Tools, Global Options. Can you see the pop-up window?
Yes.
Thanks. In this global options, you can modify something called your working directory, which we'll get to in a little bit. But you also want to make sure that this box is unchecked and that you're never saving your workspace. And the reason why these are important is because you want to, every time you open up RStudio, you want to make sure that you're opening an independent session. So it's not reloading something from a past session, because that can cause errors in reading data and analyzing data. And you can also modify the appearance. Don't be afraid to play around with these options. It's not possible to break something. Yeah, it's okay to play around and see what layout, what options work best for you. So I'm going to zoom in just one more, because if you're watching this next to your own RStudio that's open, I want you to be able to have the maximum visibility. And I also want to cover, before we begin in the coding, how to ask for help. And as Andrew referred to, typically when you're programming, you'll have RStudio, a window of RStudio open, and on the side, you'll have Google open, because you'll end up searching, how do I remove my plot axes in ggplot in R? You'll end up Googling everything that you want to do as you're coding, and that's very normal. And when you're Googling, one of the most common resources that will pop up is a website called Stack Overflow. This is a great website because it's where a lot of questions have been asked online, and a community of users have answered them. So a lot of your answers will end up coming from Stack Overflow. That's a good resource to refer to. All right, so if you don't have this script open, this script window open, go ahead and select this plus button, this green plus button in the upper left corner, and select a new R script, and you can start to see some of the keyboard shortcuts, Control-Shift-N on my computer, and that might be different for if you're working on a Mac. So if you select this, you'll open up a new script. I have one open. If you Control-S or save using this floppy disk image, you can name it something descriptive. If you were in last week's sessions, remember one of the tidy rules we learned about is that our name should be short but descriptive, and this will help our future selves return to that code in the future. Okay. And so let's begin with an introduction to R. R is many things. At its most basic, R is a calculator, right? You can use R to do simple arithmetic. The power of R, however, is in its ability to store and save scripts for later use. So we can store something called objects. We're going to create an object called weight_kilograms, and we're going to save a value into that object. So there's two lines here that I want to point out. You can differentiate them by their color. And that's because when you put this hashtag symbol, R recognizes that as a comment, and it understands that anything to the right of that hashtag is not code, it's not going to run. It's we can think of comments as notes, and they typically are used to explain what the code below it does. And this is really helpful to document the different steps of your code so that a collaborator can understand what you've done, or your future self can understand what you've done. And then you can see, and when a line doesn't have that hashtag, R understands that as a line of code. And so when you you can run code in 2 different ways by selecting the run. And notice how it'll send the comment to the console, but it'll send the code to the console as well. So the comment is not doing anything, but the code, it's running. And we know that because now in our environment, we have an object stored in our local environment. And what that means is now R will remember that we have this object, and we can call it, we can call that object again. Now, another component of this code is something called an assignment operator, and that's composed of the, what is that? The less than symbol followed by a dash, and there's a keyboard shortcut to that. The keyboard shortcut is Control Enter on a Windows or Linux machine, or I think it's Command Enter if you're working on a Mac. And programmers are really big about using keyboard shortcuts so they don't have to move their hands away from the keyboard. Something about speed, but so I'm selecting Control Enter to send that code to the console where that command is being run. And in terms of object names, just like our script name, we want that name to be concise. We want it to be descriptive, and we want to be consistent. So if we're using all lowercase letters here to define our object, we want to stick to lowercase, because another important thing to know about R is that it's case sensitive. So if we accidentally typed in weight, kilogram, return the value of this object, we'll get this error message that, oh, this object was not found. And that's a good flag for you, because you know there's an object called weight_kilogram, and then you go back and check and you realize there's a typo in the case. Many errors in R when you're beginning are typos or syntax, and we'll see a few examples of that in a few minutes. Okay, so we've seen an example of an object. What an object is, it's a variable, right? When we run this, it doesn't print anything. We had to run the name of the object itself in order for R to print something. And because we've created this object, now we can do arithmetic with it. For example, we can multiply this object by 2.2. And we can overwrite the value of the object with a new value. So when we do this, R is overwriting the previous object value. And because we can create objects, we can create new objects to store the result of this arithmetic on an existing object. So say we are creating a new object, a new variable called weight_LP for pounds, and we're asking R, convert this existing object, multiply it by 2.2, and save it in this new object that I've created. And so now we're seeing that new object stored in our environment. I recommend saving your code frequently. This is good practice in case your computer crashes and you've done a lot of very complex code, then you don't have to worry so much about losing lost work. So we've talked about saving code, we've talked about comments, and now let's talk about built-in functions. Another powerful thing about RStudio and R in general is that it has built-in functions for statistical analyses, for graphical analyses as well. It takes time to remember all of the built-in functions, and that is through, it's like learning any other language, right? It's through use and practice. So let's see an example of some of these built-in functions. And so I'm going to make a note to myself, examples of some built-in functions, so you can see those comments in action. Let's create an object called weight_kilogram. And inside that object, let's store something called square root. I know this is a built-in function in R, sqrt, and we're seeing another functionality of R. Hopefully you can see that little yellow box that appears. When you type in the name of a built-in function, you'll get this yellow box reminding you what R expects from you. So it's expecting an argument X. So it's expecting some sort of value for this function. So let's give it a number, square root X, and I'm going to run this, send it to my console. Remember, I'm running the command, and so it's not printing the value. I can also see the new value in my environment, right? It's overriding the existing value. So you have to be careful when you do that in your own code. And we can also see, if we were to question mark the name of the function, that is a way to tell R to look up the help documentation for this built-in function. So we can see information about this function, and most of the time you're skipping a lot of these details and scrolling down to the bottom, because you can run examples. So let me show you that again. You can run examples through here, or you can run them in here. So let's run them in here, and it'll show you a nice example of the code, which I found to be really helpful. Let's look at a function that has more than one argument. So an argument is, we look up at the help. An argument are all the things that R expects inside of those parentheses. So let's look at a function called round. This round function, it rounds a number to a certain number of digits. So again, we're seeing that little yellow text box that is reminding us of what arguments R is expecting. So it's expecting some sort of numeric value, and then it's expecting something called digits. So it allows you to specify the number of digits that you can round to. Because it says digits equal 0, I know that that's the default. So if I don't specify the digits argument, it is going to default to the default value. So let's look at an example of what that means. So let me run this. Control Enter. So the default is digits equal 0. I didn't have to tell R to round to that digit. Now let's say I do want to specify R to round to only 2 digits. I use the argument name, and in some instances, let's look up question mark round. I'm curious if I don't have to specify the name either. Yeah, so because R is expecting 2 arguments in this specific order, R is smart enough to know that the first value you give it is X and the second value you give it is digits. Now I could, reverse this order if I name the arguments, and R is smart enough to know that you're naming the arguments, so to use that function in that way. Okay, so most of the time we've seen examples of objects, we've seen examples of some of the built-in variables, built-in functions. Let's look at an example of vectors and data types. A vector is one of the most common and basic data types in R. It's what you'll primarily use when you're analyzing data or making graphs. And vectors come in many different shapes and sizes. So let's create a vector. Most of the time you'll be creating a vector from a spreadsheet, but we'll do that in a minute. Let's create our own vector manually. And we do that by using this built-in function called C. So C is a function that combines values into a vector or list. So I'm going to tell R, okay, combine these values into this vector, into this object I'm calling weight underscore grams. I'm going to run that. And then remember, it doesn't print. To print, I have to call the name of the object. So now in my environment, I see this vector. It's numeric, so that's the type of vector. And it's got a dimension of 4. It has 4 values. And I can see a snippet of these values. If they were longer, you can get a sense of those first few entries. A vector, it doesn't have to contain just numeric values. Vectors can also contain characters, animals. So let's create a new object called animals, and I'm going to tell R, okay, R, in that new object, give me a series, combine these character values into a vector. So I'm going to give it a series of names, and these can be characters, they can be gene names, they can be park names. I'm going to run this. Oh, good. And I've got a number of weird error messages. And most of the time, you get really good at decoding error messages. And this is strange because, I don't know. That's strange. Okay, it doesn't look like it was fatal or anything. So we'll continue, and then I'll tell R, okay, print the value of that vector. So now we see animals in our environment, and now we can see the data type is character, CHR for character instead of numeric. A lot of the times when you import your data into R, you want to be able, one of the first steps is to inspect the structure of your data. So you can use, let's do it up here so we can save. So you want to use a few built-in functions like structure. I'm using this semicolon so I can type in multiple lines of code on the same line. And that's because we're working on such small windows. Normally, good coding practices is to keep one line of code on one line, but for this workshop, so we can keep things more compact, I'm going to use the semicolon there. By using these built-in functions, you can get an overview of your data. You can see the class. So here it's character. We're working on very small vectors, so we can see them here, but imagine you're working on very large data sets. It's a good way to inspect and summarize your data. Okay, now we're going to import data. We've seen a few examples of how you can create data manually in R, but most of the time you'll be importing data. So hopefully you were able to download the data beforehand, the combined.csv file. If not, it's located at the top of our SIP help sheet. So we want to load this data into our studio. There are two ways of loading data. One is manually. So if you've never used R before, this is the easiest to me. You can import from text and find where you saved the file. I know it's called combined.csv, so I'm not going to scroll through all my files. I'm going to type the file name and I'm going to select open, and it'll take you to this window, this pop-up window where you can inspect whether R is reading it appropriately. Sometimes R can have a hard time detecting the column names. So you want to come over here and make sure that that heading button is selected to yes, if there's a header, a column name. And sometimes it doesn't detect the correct separator. So this is a .csv, so comma separated value file. CSVs are more common, but federal and state agencies I know often work with tab delimited files as well. But I'm inspecting it here. Everything looks okay. So I'm going to scroll down and select import.
Sorry to interrupt. Also, there's the strings as factors button that is one thing that also trips up a lot of people. So there's a right there. If you don't check this, your strings, which we have been working with, will be converted into a factor, which are like good for analysis, but kind of confusing for beginners because you can't change them.
So make sure this box is checked. Great. Thanks for mentioning that. Import. Okay. So now we've got that argument here. So that's the first way to import data. The second way to import data, and you see I love this because I'll do the manual import, then I'll come over here and I'll paste it in so that I'm saving it for my future self. I can just run the code and I don't have to do anything manually. I will want to automate as much as possible. So this brings us to another important concept to distinguish. It's really important when you're thinking about reproducing your code in the future or handing your code off to someone else to use something called relative paths. This is more like an absolute path, and that's because it's specific to my computer where I stored the data. So we want to make this absolute path into a relative path that it can be generalizable to anybody's computer, right? And that we remove anything that would be specific to my computer. So by making this a relative path, now anyone can open this run this code and it should work as long as their data is stored in something called their working directory. So if you type in another built-in function called getWD, it will show you the absolute path on your computer where R is reading. So R points to a specific folder on your computer. I have designated the default working directory in my RStudio to be downloads. So that's where I tend to work with data. And you can specify that in that global options. So tools, global options, and you can specify your default working directory. I find that easier than specifying my working directory manually, like set working directory to this long weird thing that I never remember what the folder names are. So that's how I've customized my RStudio, so I don't even have to set my working directory. I know it's pointing to my downloads. That's where I'll keep my my files. And if, yeah, there's a whole nother step for tidy coding practices, but as you continue your programming journey, you can get into more detailed ways of storing and organizing your data. So hopefully you have the data loaded in your environment, and you can see it here. And there's a few ways you can visually inspect your data. If you select this arrow button, you can see all the column names designated by this $sign. And you can also see the class, so int for integer, factor, these factors. You can also use built-in functions like view combined if you accidentally close it out. And you can also, another handy thing, if you want to get to previous lines of code in your console, you can use the up arrow. So I accidentally closed the combined. I want to run that line again. Okay, so we've read the data into R. I go back to my code, and now I want to load the libraries that we're going to be working with. So a library is they're different packages that have different functions built into them that don't come standard within RStudio. So let's go ahead and load the library tidyverse. Hopefully you're able to install it. If you forgot to install it, the built-in package is install.packages, and I think it expects it in in quotation marks. Okay, so assuming you've got that, sometimes there'll be messages. Here it's telling me that there's a function that is the same name as in another package, and most of the time that's okay. Yeah, most of the time. All right, so we've loaded our libraries, we've loaded our data. Now the first thing you want to do when you load your data, you want to inspect it. Some of those built-in functions include something called head, so you can see the header. So I need to remember the name of the object that I stored that data in. Head gives you the first 6 entries for all columns. So I'm inspecting this. Okay, looks good. I can see there's some NAs. That's always important to note. You can also use something called summary. And it'll give you a summary, the minimum, maximum values, the means, and if there's some NAs. And that's good to know when you're thinking about the statistical analyses that you need to do, some functions don't work on NAs. So let's see an example of that. Let's use a built-in function called mean. Let's calculate the mean. And we want to call a column within this object. To call a single column in this object, we can use that $sign operator. And look, what's so convenient about R is that our studio is that it has these auto-complete. So as soon as I put in the $sign, it'll show me this drop-down menu of all the columns. So I don't have to do any typing. Let's say you have hundreds of columns though. As you begin to type, it'll winnow down the options based on those, the sequence of letters that you typed in, right? And then to auto-complete, you select the tab button. So I don't have to type out the whole name. I can select the tab button on my keyboard and it'll auto-complete. So now I'm going to run this using Control Enter, Command Enter, and I'm expecting a value because I know hindfoot is an integer. I'm expecting a value to return back, and that's because it's saying NA, and that's because, oh, I probably have NAs in my in that column. And I'm guessing if we look under question mark mean, it has an argument called na.remove equals false. That's the default. So I'm going to change that to true. So I'm asking R, okay, R, calculate the mean for this column, hindfoot underscore length in the combined data frame, and remove all of the NAs. Oh, now when I run this, I get the value returned. All right, so there is one more thing I want to point out before we get into ggplot, and that's indexing. So I'm going to make a note, indexing and subsetting data frames. So our data frame, we imported a data set that became a data frame. Data frames are the most common ways to interact with data in R. And we're going to see, we saw one example of how to subset a column. So subset a column by using the $sign notation. So maybe I want to tell R, okay, R, create a new object called month, and inside month store this particular column from my combined data frame. Of course, there's other ways to call or subset data frames by using something called index. So an index is represented by these square brackets. So let's say I want to subset a particular row and column within the combined data frame. I can use the square brackets, and those square brackets, inside those square brackets goes row, comma, column. And I always remember, I used to always forget the order until I came up with something to help me remember. I grew up in the South where RC Cola was really popular in the 80s and 90s. And so that just helps me remember row, comma, column. So if I wanted to call, okay, give me the value for the first row from the first column. So R is pulling the first row and the first column, the value in that cell. Now there's many different ways to iterate off this basic format of our row, comma, column. Let's say I want all columns from this first row. I'll just leave that column argument blank, and it'll return all entries for the first row. And vice versa. Maybe I want all rows for the first column, and it'll, it maxed out the number of entries. The way I use, typically you're calling multiple columns, multiple rows, and we use that using the colon. So let's say I want, okay, rows 1 to 3. Notice I'm using that colon to indicate that this is a sequence. And I can do the same thing for column rows 1 to 3 and columns 5 to 6. And I'm going to run this. So it's pulling those specific cells that I've indicated. And of course, I can store this in a new object. Let's say I want the first 6 rows and all the columns. And remember, it won't run until I run the object name itself. And so this is exactly what that built-in function does, right? It uses that index. Okay, we have just enough time to go over ggplot. We could have a whole workshop on ggplot. ggplot's amazing. I'm going to pull up my notes here. A ggplot is a package, so that means we need to call it library ggplot. There it is. I'm going to use my tab to autocomplete so I don't have to type in so much. All right, no issues. And so what's so powerful about ggplot is that it's a way to build figures iteratively. What that means is that you're modifying different aspects of your plot line by line. Let's see an example of this. First, let's look at the help, because I want you to see the arguments that ggplot expects. And I'm going to comment this out. So ggplot, the different arguments that it expects something called data, like what data that you want to use to plot, and then something called mapping, and that's what columns do I map to X, what columns do I map to Y, and these, which I rarely use. So let's see ggplot in action using our combined data. So let's follow this template. Okay, let's tell it, do this ggplot, use the combined data frame, and mapping my aesthetics. So AES is aesthetics. It expects an X and Y value. So for X, let's equal to the weight column. Did I make weight? Yes, weight column. Y equals hind foot length. And we close a parentheses. R is useful in that it'll highlight the matching parentheses. And if you forget your parentheses, a little X mark will come up on the line number. And sometimes it's useful because it'll tell you what the error is. In this case, it's an unmatched opening bracket, which is just a general term for any parentheses or square bracket. Okay, I'm going to run this now. And hopefully it runs on yours because I've been having some issues with my graphics. There we go. Okay, so when we run this, you should hopefully see a plot, and we've got the X and Y axis, we've got axis numbers, but there's no data, right? Because we didn't tell R what kind of plot to make. The kinds of plots are called geometries or geoms, and there's different kinds. To add a new layer to ggplot to designate the geom, we need that plus symbol followed by geom underscore. Let's do a scatter plot, geom point. And that's a function, so it expects those open and closed parentheses. So now let's run this. My cursor's on the last line of this code. When I do Control Enter, it'll run both lines because both lines are connected with this plus symbol. It's telling me that it removed rows that contain missing values. Those were our NAs. And now we can see the plot at those points that were added. You can also use different geometries like a line geometry. For this, a line plot doesn't make a lot of sense. So that's geom point. And now we can start to see the real power of ggplot. So let's say maybe we want to specify the color of those points or the transparency of those points because there's quite a lot of overlapping points. So there's something called alpha for transparency. Let's rerun that again. And now we can see the points have transparency. Let's modify this so that the points are, whoopsie, light blue. And what's great about R is it'll recognize pretty much any color name from like any crayon color name, like green or even like spring green or light green, right? Like you can also look up hex codes for a very specific color if you are working with a particular color palette that you wanted to use. So let's run this now, and now it'll modify our plot with put the points as a new color. We can also specify that maybe we don't want all points to be the same color. Maybe we want the different points to have the color depending on their species. So we can designate this using the aesthetics, because now that aesthetics argument expects color equals species ID. Now notice how I didn't have the aesthetics expects arguments X, Y, and other arguments, but I didn't have to specify what X, Y was because in my ggplot I had already specified. Well, let's run this. And now it might take a minute. Now we have different points colored by the different species. All right, let's see one last example of a box plot. Let's call ggplot. It's reminding me of those arguments. Okay, ggplot, take this data frame called combined. For the mapping, and it expects the mapping. We don't have to name it. We can reduce our text. Aesthetics X equals species ID and Y equals weight. Let's use that plus to designate what kind of plot. Let's look at an example of a box plot. I already have an X marks here, telling me unexpected end of document. Yep. Okay. It went away. Let's see an example of the box plot. There's different ways we can customize ggplot. Again, we could designate the color is red. Let's see what that looks like. Maybe we want to add the points on top of it as well. Or maybe all these points are so overlapping that we can't see them all. So we can use a built-in function called geom jitter. One of the last things I want to cover is themes. ggplot has many built-in themes that make it easier to customize your plot. I am not a fan of these gray background. Well, we can use theme, and you can type in theme underscore and see all the different themes. I am minimalist. Let's try out the theme minimal. So it gets rid of the gray background. I would even go further and remove the gray lines as well. And you can play around. Yeah, this should be fun. This should hopefully give you a sense of exploration and discovery. You're learning an entirely new language, just like French or Mandarin or Portuguese. And so have fun with it. Remember, this is a very brief overview of some of the functionalities of R, some of the tools. And I hope you enjoy learning a new language and become multilingual and confident in your programming journey. We have a few minutes and I'm happy to take questions. I'm happy to stay a few minutes after as well.
Thanks, Catherine. Does anybody have any questions? You can type it in the chat, or you can raise your virtual hand using the reactions button that's at the bottom of your screen. I know it was a lot we just covered. Give it like one more minute, and then if nobody has a question.
I just wanted to chime in really fast. I added a couple really handy cheat sheets based on ggplot and on dplyr in the chat. They're just these PDF documents that are all based on what Catherine was talking about, and they list out a lot of the functions that you might need. They just, yeah, they're super useful, and I wanted to share those.
Thanks, Alex. Yeah, all the resources you could ever want or need are pretty much there for you. You just got to know what you're looking for. So,
yes.
Okay, well,
yeah.
Go ahead, Catherine.
Yeah, I was just saying, figuring out how to decode error messages. Sometimes you can copy and paste your error message into something like Google. I've even started to use ChatGPT. There's a plugin for RStudio for ChatGPT that allows you to ask ChatGPT, like, how do I solve this error message in R? And it'll get you most of the way. So good luck, everyone, with your programming journey.